Hello friends, today's question. A particle free to move along x-axis has a potential energy given as U of x is equal to k 1 minus exponential e raised power x square, exponential minus x raised power 2 for minus infinity x to plus infinity, where a is a positive constant of appropriate dimension. Then, so we have to find out which of these four conditions are true. Correct one. Okay, so we are going to one by one take these options and try to find out what it means according to the given equation, and from there we are going to drive the conclusion whether that statement is true or false. So first of all, we are given that potential energy of the particle. Potential energy of the particle governed by U of x is equal to k 1 minus exponential function and minus of x square. So let us find out whether option A is correct or not. Option A. So we have to find out the equilibrium position away from the origin. The particle is unstable equilibrium. So we are going to find out the equilibrium position, and to check at the, you can say, the equilibrium points, we know that at that particular point where the equilibrium is possible, the force will be equal to 0, and we are given the potential energy, and for that particular point we can find out that the derivative of potential energy with respect to F will be giving us a force. Okay, and the further solution is going to help us to drive the conclusion. So let us start that to check the equilibrium points. Equilibrium points, the force is equal to 0. Force is 0, which basically means that the derivative of potential energy with respect to x should be equal to 0. Derivative of potential energy with respect to x should be equal to 0, or we can say that force at any point x will be given by derivative of potential energy with respect to x. And let us find out the derivative of the potential energy, that is du by x will be equal to k, and this is minus, and we get here 2x and this is our exponential minus x square, and we have minus here. So we get that du by dx is equal to 2kx exponential x square. So setting du by dx is equal to 0, you can say du by dx is equal to 0, so which basically means 2kx exponential minus x square is equal to 0. So from here we can easily say that our x is equal to 0. So it means the equilibrium is only possible at only one point, that is at origin, that is x equal to 0. From here we can say the equilibrium is only at point at x is equal to 0, or we can say at origin. And in the option A, it is given that at points away from the origin, the particle is in unstable equilibrium. But we just proved that there is only one position of equilibrium, that is at origin. So this is not the correct option. Okay. We can say option A is our incorrect. Option A is incorrect. Now let us start for option, you can say option B. Option B. And option B, it is asked that for any finite non-zero value of x, there is a force directed away from the origin. So we are going to take a non-zero value of x and try to find out the direction of the force, whether it is towards the origin or it away from the origin. And we just found out the equation for the force. So we can say force is given as f of x, which is equal to minus du upon dx. So therefore we get that fx is equal to minus 2kx, and we have exponential minus of x square. Okay. So therefore in the question it is given that, or rather we can say in the option that is given for non-zero value of x. So you can say for non-zero value of x, so which basically means that x is not equal to 0. So for x is not equal to 0, from this equation we can say that the force is directly proportional to minus of x. Force is directly proportional to minus of x. Therefore we can say that force is directly towards the origin, not away from the origin. Therefore force is directed, it is directly proportional, directed towards the origin, and not away from the origin, So therefore option B is also incorrect. Option B is also incorrect. We can say that option B is incorrect. Next, option C, it is asked that we have to find out the energy. So it says that if the total mechanical energy is k by 2, then it has its minimum kinetic energy at the origin. So we have to find out what will be the value of kinetic energy and at what position it will be minimum. So let us try for option C. Option C. Okay. And we have the energy equation, which is given as, rather we can say potential energy. Potential energy is given by u of x is equal to k 1 minus exponential minus of x square. Then we can find out what will be the potential energy at the origin. So you can say potential energy at origin, that is x equal to 0. So we get u of 0 will be equal to, this will be k 1 minus exponential of 0, and this will be equal to 0. And the value of, you can say, the limits of the x are given from minus infinity to plus infinity. Okay, so let us find out what will be the potential energy at infinity, or we can say when x is very large. Potential energy at infinity, or we can say when x is very large. So we can say our u when x tends to infinity will be equal to k 1 minus exponential, and this is our minus of infinity, and this will be equal to value of k. And we also know that the total mechanical energy at the origin will be equal to kinetic energy at the origin plus potential energy at the origin. Okay. Total mechanical energy, and total mechanical energy is always the sum of the kinetic energy plus potential energy, and this is true for any location of the particle. So it means when kinetic energy at x equal to 0 plus potential energy at x equal to 0, that should be also always equal to our k by 2 that is given to us. And we just found out that the potential energy at origin is equal to 0. Therefore we can say that our kinetic energy at origin will be equal to k by 2, and this is equal to total mechanical energy. Okay. This is equal to total mechanical energy, and from here we can draw the conclusion that the kinetic energy at the origin is maximum, not minimum. Okay, because the energy cannot be greater than k by 2, and the kinetic energy at the origin is our k by 2. That is a maximum value. Okay, so the kinetic energy at the origin is equal to k by 2, which is equal to total mechanical energy, or we can say the maximum energy. Maximum energy. Therefore, we can write that kinetic energy is maximum, not minimum at origin. So it means the statement C is also incorrect. Okay. So statement C is also incorrect. So you can say option C is incorrect. And now let us find out what will be our option number D. Okay. Option D, and it is as it is a single correct answer. So from here we can easily drive the conclusion if first three options are incorrect, so D has to be correct one. Okay. But we can still prove it, and it is asked that for a small displacement from x equal to 0, the motion is a simple harmonic. So we are going to take a small displacement which is equal to x equal to 0 and try to prove it that it is a simple harmonic. So let us say that for small displacement, we can write that u of x is approximately equal to k 1 minus 1 minus x square. Okay? Because the original equation of energy is our u of x is equal to k 1 minus exponential minus of x square, and we can say Taylor series expansion to get this result. Okay, we can say using Taylor series. So this is going to give us this equation, and if you open this equation from here, we can easily say that u of x will be equal to our k x square. U of x is equal to kx square, which is our you can say a quadratic potential. This is nothing but a quadratic potential. That means the energy is a quadratic potential, okay, and which is in the form of a potential energy of a SHM. Therefore, from here we can say that this is in the form of potential energy of SHM. Form of potential energy of SHM. Therefore, for small displacement, the particle is executing SHM. Therefore, for small x, the particle experiences SHM. SHM. Therefore, the option number D is the correct option. Option D is correct. So this completes the question. Thank you.